So before going into Linux commands and scripts and shell scripting and all, I would like to show you Docker. Why? Because it has a lots of correlations, so that is important. So mind it, you know, uh, I'm teaching you platform training, where platform which is basically Linux is a platform, Linux in the VM, Linux on the cloud, and Docker is a platform. Kubernetes is also platform. Kubernetes is platform. VM you can get it in your laptop and cloud. So cloud, which we have multiple cloud like AWS, Azure we have, and Google Cloud. We have multiple cloud though. VM, VirtualBox, and all kind of things. We can hypervisor. You can get it. Okay, so these are the platforms. So Docker is a platform considered as a platform where you run applications. Okay, so it's important to understand the Docker. And now I'm going to talk about the fundamental, but little bit deep dive into later sessions actually. So first question is, what is Docker? That is the first question, right? Anyone have idea what is Docker? Anyone?
Uh, it
All,
it it distribute a machine into separate uh, environment for separate technologies. For example, uh, one
okay, I'll stop you. So anyone who asks you what is Docker, simply say, don't give too long definition. Say, hey, it's a container management tool. Okay, it's a container management tool or a platform also you can say. It's a tool and platform. So now here, next thing is, what is a platform and tool will do? So you know that any tools which we use over the period of time, it will save cost. Okay, save time and improve quality. Improve quality. Sorry, I got some. Sorry, improve quality. Okay, so first, if someone will ask you, hey, what is Docker? You say container management tool. So, why we need Docker then? Why need Docker? So to run container, simple. To run container. Now, what is container? This is something which we will discuss in a next session in detail. That is a very important question. What is containers? Okay. But here, what is containers? So for time in, containers as your applications, simple running. So, or you can also say you can run application in container. In a simple way, I'm putting it right way. We'll complicate a little bit later. Okay, so you can run apps in containers. See, earlier where we were running the apps, earlier we were running apps in desktop. You know that. Then after that we are running in the where we are running laptop. Laptop desktop is both physical devices. Then from last 20 years we are running the container in virtual machines. Correct now? Sorry, application in virtual machines, and now you are running in a container. See how we are migrating. So you were running apps earlier in desktop, then laptop, virtual machines, now containers in a simple way. So what is Docker? Docker is a container management tool. So tool will help you in what? Saving cost, saving time, improving quality. Now you'll ask a question, how it can save cost? Okay, so it's simple. Containers consume less CPU, RAM, storage. and no licensing cost. Okay? Just avoid the spelling mistake. So saving cost. So here you run application in the desktop, laptop, or VMs. You require lots of CPU, RAM, and storage, and you require the operating system to buy out also. But here in container, no licensing cost, CPU, RAM, and all. How this technical discussions will do later. Now I am doing the at a high level discussion. Saving time. How it can save time? So here understand in a simple way. In a desktop, if I want to install and run applications, how much time it will take? Desktop and laptop. Let's say 1 hour. This is install everything. Operating system, applications, Apache, database, or no. VMs, how much time it will take? Five minutes. Container, how much time it will take? 1 second. See, so you want to run application in container? 1 second. You want to run thousands of application? 1 second. Saving time. Correct, no? And then improve quality. So quality means what? Which quality? So we are a software engineers. Software quality. So if I save your time and cost both, so of course whatever the time you get it or cost you can spend on the quality, improving the quality. Okay, so did you understand the meaning of tools and platform in this context, Docker context? How the Docker will help you, all of you?
Yeah.
Okay, so
I have
now
a
make,
question. So when you say
yeah,
in the application in the container, what do you mean by exactly that? I mean, so whatever developers build the code, that you are deploying, how it's going to be?
yeah. Sanjay, your voice is breaking actually for various background noise is coming, but I think I understood your question. So basically you want to know containers. What is container? That's what I said. I'm not complicating the container definition now, technical definition, but for time being you just remember containers is running your applications. Simple. Okay, that means container is running. Now anatomy of containers, architecture of containers, how, what is containers, how it works, this we need to discuss actually. So I'll first I will my approach is something like this. First I'll teach you how to ride a bike, then I'll teach you how to do the manufacturing of bike, something like that. Because if you know the functionality of bike, it's easy you to learn that manufacturing process and all. Okay, so that is the way. So now this you understood, all of you, what is the why we call it tool and platform? Because tool and platform will save cost, save time, improve quality, and all these benefits every tools will give it to you. This logic is for everyone. Make sense, all of you? So if someone will ask you why you are learning Docker, so you should say same region, these are the regions. Okay, now management means what? Management means what? So guys, I don't know how many of you have created a virtual machines. It's there, this technology is there from last 20 years. But what do you do in the virtual machines? VMs world, what do you do? This one I am talking about. Okay, so VMs, what you do? You create a VM, then start the VM. You can stop the VM also. You can restart the VM also. You can do you can do the kill the VM also. You can pause the VM also. Okay, you can unpause the VM also, and finally you can kill the VM and remove the VM. Okay, stop and kill the VM and remove the. So these are the things you can do that, don't you, all of you?
Yes.
Okay, so don't take it very, because I told you very simple way. These are the platform trainings I'm teaching you, platform. So containers also you can do the same thing, nothing great about it. So when I say containers also you can do the same thing. If someone will ask you, hey, what Docker can do? So managing container. Okay, managing container means what? Can you tell me? So using Docker, you can create a container. Using Docker, you can start the container. You can using Docker, you can stop the container. Using Docker, you can restart, kill, pause, unpause, kill, and remove. That's all. That is the reason I call it Docker is a container management tool. So why Docker? Management, what Docker can do, capability of Docker, why Docker? Are you clear, all of you?
Yes.
Simple. Now, what is a container? So functional definition, I said container. What is container? So container is running your app. Simple. You can run apps in container. Now it's a lightweight. Lightweight means when you compare lightweight, when you want to compare, then spelling mistake I guess, WEIGHT, right? Yeah, lightweight. So lightweight means when you compare container with what? Of course, you'll compare container with the VMs. So you will compare physical server versus VM, which you did it 20 years before. Okay, now you will compare VM versus container. So VMs is not lightweight. Containers is lightweight. Why? I told you, no. Containers consume less CPU, RAM, and storage. No licensing cost. That's the reason it's lightweight. That means with a minimal CPU, RAM, and storage, you can run application in a container using Docker. That's the reason it's lightweight. Now, technical things I'm not giving you because you'll get confused because lots of things is to be learned. So are you okay so far, all of you? If someone will ask you what is Docker, you will answer. What is container? Why container? What is the Docker is doing? All these things. Can you answer, all of you?
Yes.
Okay. So now this is something we will continue. So here technical definitions. Next sessions I'll talk about it. Now next questions I should ask: how to install Docker? Okay, so this is very simple. Okay, few commands, you run it and then install the Docker. So let me install the Docker first and then show you. So let me see if Docker is there or not. Docker is there, but how do we install it? So let me show you how do we get it. So click on Docker, install, and always any tutorials you are looking for it, Docker install and DevOps school, or in future also, this is the pattern. You write whatever the tutorial you are looking for it under the DevOps, SRE, MD, DevSecOps, MLOps, whatever it is, put it in this way and then put it the DevOps school. Okay, immediately the Google will give you the tutorials. So here Docker installations and configurations. Okay, now you have RHEL. I don't use RHEL right now. This is for YAM. Here Ubuntu. This is CentOS. Ubuntu, I need it. So this is Ubuntu. Click here and just go through this. These are the commands. You run it blindly in the Ubuntu. It will install the Docker. Okay. So now you see here Docker is installed. I have installed already in this machine. The machine which you got it. So just you run this command and installed it. This command. That's all. These all are apt commands, which is good to install it. So done. How to install? Done. Now someone will ask me, Rajesh, I want to learn Docker. So for that, what should I do? Okay. So I would call it components of Docker. Okay. Architecture, I'll talk about in some time. Okay. So components of Docker. That means if you want to learn Docker, what you have to do? Step number one, don't complicate yourself. Step number one, install Docker engine. Now the question is, what is Docker engine? So guys, understand this. What is Docker? So Docker is not at all a tool name. Then you'll say, Rajesh, why you are teaching me Docker then? So actually, I'm not teaching you Docker. Yes, I'm not teaching you Docker. I'm teaching you Docker engine. So Docker is a company name. Okay. So Docker is company name. So when I say Docker, that means their first product is Docker engine. Docker as a company, they have a multiple products actually. Okay, so please remember, they have a SWAM also, engine also, registry also, community edition, enterprise edition, lots of things they have it actually. Docker desktop, so many things we have. I'm teaching you Docker engine, which is a most important one, and that is their first product. So Docker is a container management tool, Docker engine, and this tool is written in Golang. Golang. So now guys, maybe not this year, but next year, I will introduce the Go as part of this course also. Why? Because most of the tools nowadays has been written in Go. Now we are focusing on Python in this session, but maybe next year we'll have to learn Go also. Why? Because Docker is written in Go, Kubernetes is written in Go, Terraform is written in Go. So all these tools, latest tools has been written in Go only. Okay, so if you want to customize it, you Docker, You have to know the Go. Okay, so this written is Go. Now they have a multiple releases actually. Okay, what are the release? So they have one community edition which I'm teaching you, and enterprise editions we have. Enterprise edition. So they have two. So which one I'm having? Let me check. See that this is the community edition, right? Community edition. Okay, so now you'll say, Rajesh, what is the difference between Docker community and Docker enterprise? So just look at this and community and enterprise. This you don't need to know because it's Docker is getting deprecated. I'll tell you a little bit later. First, I'll want to teach you Docker, then and put the DevOps school. Okay, DevOps school. Enter. And here you can find the difference between community editions and enterprise edition. For knowledge purpose, it's good to know. Let's say if you are a management and you are in a discussion, architect discussions and all, you should know that. But for the engineers and all, no need to get into that right now. Okay, so they have a two releases actually. Now what is a version of it? What is a version of it? So version is 22, I guess. Let me check that. It always new release. So here is a 25. You see I installed 25. I think I installed last week only, so it's the latest one. So 25. Okay, every month we have a release actually. So this is the Docker. Are you comfortable now? If someone will ask you what is Docker, why we need Docker, what is the advantage of Docker, would you be able to answer these questions?
Yes.
Okay, so now why Docker, what is Docker, all these things. So now come back to the main questions, components of Docker. That means if you want to learn Docker, what to do? So first install Docker engine. So just now I installed it. I mean, through this instruction you can install it. So then in Docker engine, what do we have? I'll tell you. So here we have one topic which is called Docker architecture. Okay. So any tools you learn, please understand the architecture. Without architecture, you will not be able to survive in the DevOps domain. Okay, so first thing in architecture, this is you. Every time there'll be you, and you will talk to Docker client, and Docker client talk to Docker server. Docker daemon also we call it. Daemon, right? Correct? No, DAEMON. And then Docker daemon will talk to the container D, and container D too will talk to the kernel. Okay, we'll in detail we'll discuss actually, but this is a whole flow. You will send the command to the Docker client. Okay, Docker client send the command to the Docker server, which is running as a daemon, and Docker daemon will send this instruction to the container D, and container D will talk to the kernel. Kernel just now before that only I taught you, correct? No, so kernel you know that, and container D is the one which is the utility which we need to learn in future. Not now, but future. Why we need to learn future? Because you know what, container D is become a standard platform. Now if I go to the Google and here I put the container D, see here, just read this one. What is a container D? So container D is a industry standard container runtime. That means if you want to run any containers anyways, you have to use a container D. This is industry, this has become an industry standard. So that means what was the earlier world in terms of container? So we were having lots of container runtime interface. Let me show you here. Container runtime interface and DevOps school. So earlier we had a lots of container interface, runtime interface, lots of more than 50 options. See here. Here you see multiple. This document has a consolidated list of everything. So many. But you know, scientists realize that this is going to be mess. So let's have it only one. So they developed and maintain the container D. That means it's become a only one common industry standard. Those who wants to migrate to containers. Okay. Now will you will have to learn this container D in future, but not now because till the transition is going on for most of the stuff. So now this is something which you have. Now what is a Docker client? So Docker client, let me show you here which Docker. See, this is the client, and which Docker D, this is the server. Now Docker is running in the right now it's running. See, it's running here. Okay, so this is the client. You know what? These two things together is called engine. Okay, these two things together called Docker engine. It's a one product by the Docker company. Are you okay so far, all of you? Hello.
Yes.
Okay, but any idea who has developed the Docker? So this was developed by Solomon Hykes. Okay, this you please remember that. He is the person who was working in Docker, but recently, I mean last year July, he has left the company actually. Solomon, it's a Solomon Island also, right? Solomon Hykes. Look at this. Spelling mistake actually I'm doing here. Solomon Hykes. So here, he is the one. Okay, this is the guy who's the father of Docker, you can say. Okay. Okay, so now this is the introduction of Docker and why do we need a Docker, advantage of it, architecture of it, and all kind of things. Now come back to our main questions. What are the components of Docker? So here components of Docker. So first thing, you install the Docker. How to install? I shared the instruction. You just install it. Now mind it, you need a Linux for it. Okay. Then you say, Rajesh, can I use the in Windows? Don't get into that right now. Okay. Though you can install in Windows, certain versions are supported in Windows, but 99% we will practice in the Linux only. DevOps guys means Linux. Okay. So start loving the Linux. Okay. So install the Docker engine. That is the first step number. Step number two, what do you have to do? So you have to download Docker image. Now this is a very important question. Then you'll ask, what is Docker image? So I'm not going to answer this question right now. Okay, but I will ask. I'll put it in this way. Uh, Guys, when you create a VM, what is the important things you need it to create a VM virtual machines? Tell me, all of you. What are the important things you need?
Mm,
Operating system.
Operating system. Okay, fine. Operating system, what you have? I mean, how do you get it? Operating system?
Image.
Image, yes.
Um,
So here we call it machine image. Okay. See, different names we use it in the world. I mean, the depends. So sometimes some people call it machine image. Some people call OS image. So I don't know how many of you have created a VM. So let's say if you create an AWS, that I need one image which I call it what is that? AMI, Amazon Machine Image. Now, if you go and create a VMs on the Azure, then you have a VM image. Okay, but if you create a image, I mean VM in the this one, what is it? VirtualBox, VirtualBox. How many of you have created a VM on a VirtualBox? What you need in this image? What was the need for it? ISO image, right? Correct now?
yes, I saw. Yes.
Yeah, ISO image. You downloaded. I hope you remember. You can download and create a VM. So you need a VM image. Okay. So now this is called machine image or OS image, whatever you wanna call it. I don't mind actually. People are using different name. But you know what? What it contains, that is important. So VM image contain few things. Okay. What it contains? Let's understand that. So it contains one thing which is called boot file system. In simple way, this is the kernel basically. Okay, boot file system, and then it contain root file system, root file system, and then it contain user file system. The spelling mistake, please ignore it. I'm not focusing too much. And the last one, it contain application file system. This whole things together is coming in one image. Okay, one image. It has a everything: boot file system, root file system, user file system, and application file system. Now you will say, what exactly boot file system, root file system, user file system, application file system? Let me show you in a simple way. Boot file system is a kernel. Just now before this session only I had a kernel session, right? So can you please help me? The kernel code runs where? Anyone remember that?
Um,
Kernel
RAM,
space.
right? RAM, right? Bootloader is run is not ROM, and kernel is running in the RAM, correct? Now stored in the RAM. So basically you can download that. It's all, this code is available in the GitHub free of cost for everyone. Anyone can go and download this file system. Okay, so this is the code. Actually these all are code, but this code is kernel code. Just now we discussed. Now what is a root file system? So let me show you. Sorry, root file system DevOps. Cool. So guys, have you seen this somewhere? This structure, have you seen this somewhere?
Yeah, on the Linux.
Yeah. So guys, anything you see in the root, anything, OPT, etc, home, this, that, dab, 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 this is called root file system. Mind it, anything which you see is called root file system. So do we have in Windows also? Yes, we have in Windows. Every day you interact. This is called root file system here, starting with this my PC. Sorry, this is called root file system. Start with the C. Inside the C, you have a Windows, right? This is root file system. The program data, program files, all these are root file system. Okay, simple. So this is called root file system. Again, you can see that in detailing. You can look at this and try to understand this. So now you understood that what is the root file system, all of you?
Yes, understood.
Yes.
Now, what is the user file system? So guys, my name is Rajesh. I have logged in this laptop as a Rajesh. I want to see my file system. User means Rajesh file system. Can I see that? Go to the user home. Sorry. This is my user home. And all these files and folder which you see, it's mine. It's not some other users, it's mine. So these all files which you see and folders, files and directories, not folder. Folder we call it in Windows. Linux we call it a directory. So these all files belong to me. That means user file system. Okay. So every users will have their own set of files and folders, I mean files and directories, and then that's called user file system. Now next one is application file system. So guys, in my laptop, I have installed many applications. One of the applications, typically, you know what, that's my habit. I install everything in C tools. I would be glad if you follow the same things. That way we'll automate everything. So every tools, DevOps tool I install in Windows in terms of Windows, C tools, and in Linux OPT tools, OPT directory. That's my practice. Okay. So here C tools, you see there's so many applications I have installed it. So JMeter is one of the applications. This is their file system. This is Apache file system, Apache's app. So these all files you will find in the one image, and that image which you can use it to create a VM. So sometime, you know what, sometime this applications only basic like a calculator, browser and all. Sometime they will install MS Office also and create an image, and then they will boot your laptop or VMs. So now are you comfortable with the VM image, all of you?
Right.
Hello? Hello,
Yes.
I'm audible, right?
Yes.
Okay,
Yes, able to
so
follow.
now you will say, Rajesh, I was not interested in VM image. I was interested in container, if Docker image. What is Docker image? So guys, if anyone will ask you what is Docker image, the simple definition you should say Docker image contains root file system, user file system, and application. That means Docker image will not contain kernel. Will you remember this statement? That means Docker image will not contain kernel. That means container will not have a kernel, whereas a VM will have a kernel. Because from VM image you create a VM, from the Docker image you create a container. So Docker image you see there's no kernel, so container will not have a kernel. Will you remember this, all of you?
Yeah.
Yeah. So more technical again, we'll go into the little bit later because I don't want to push every information in one go and you get lost. Okay, so first thing you want to learn Docker, no problem, install the Docker. How to install, you know that. Now you need image. So you need an image. Which image? So you need an image. Using that you can create a container. So image will have a root file system plus user plus applications. So examples here I should give it to you. Root file system, it can be Ubuntu. Then you will say, Rajesh, Ubuntu is operating system. No, Ubuntu is not operating system. Ubuntu is a flavor of Linux which contain the Linux kernel. I told you last session only, Ubuntu copied the Linux kernel, put it in their images and modify the images and added more applications on top of it. Same thing is done by 40 different vendors. So Ubuntu is a root file system and they have a kernel, Linux kernel also. But in a Docker image, they will not be having Linux kernel. Ubuntu root file system they will have, and they may be having one user, maybe root, and they may be having some application, let's say bin bash or ls or cd or whatever it is. Okay, more better example, Ubuntu, Apache, let's say your user Rajesh, and here Java application you want to run. So here Java, then Tomcat, and then here applications. So like this. So this is your root file system, and it can be sent to us also, by the way. Are you understanding, all of you?
Yes,
Yes, sir.
but wouldn't the uh, operating system image comes with the file system too? Because it's
That's what I'm saying. No, the moment you call it CentOS VM image, that will contain kernel. I just now told you. But the moment you call it a Docker image, which will have a root file system Ubuntu and CentOS, but that will have only root file system. Where is that? Here it is. Got it? So no kernel in the Docker image. Okay.
okay.
So
So
users will be there and applications will be there.
yeah, one question. So when you say VM image, right? So I believe it is you're relating in terms of the virtual box, right? Like let's say
Virt
what
yeah, this one.
Oracle virtual box, and you set up an OS image, Ubuntu or CentOS. So
Yes, yes.
all this VM image, right? So those four terms will be part of that.
Yes, VM image will
Okay.
contain kernel. Docker image do not contain kernel. It has a root file system of Ubuntu and CentOS. That means you'll root file system of Ubuntu will have, CentOS will have, plus user will have, and some certain applications you have. That will contain an image. Okay. Okay.
Okay.
So now next
So
question. Okay, fine.
the functions of kernel is combined in Ubuntu.
Yes. No. Function of kernel is combined in the host machine where you're running the Docker. Okay. So you see that here. This is Docker client, Docker server, container D, and kernel. So kernel, this is in host machine, and this is running your container. No, so this is running your container, and they're outsourcing this work to the kernel, this kernel, common kernel. Why?
Okay,
Because of
okay.
license cost and all, CPU RAM. I'll discuss more technical details little bit later. I want you to start using it, because you know what? I'll If I deep dive into the technical stuff now itself, then what will happen? You will get lost in so many things in less span of time. Okay. So first I want you to use it, dirty your hand, and then you will say understand easy way. Okay. So focus. How to learn Docker? Simple. How to install? First install the Docker engine, which you can do that. Then download the images, Docker image. And I was discussing about that image here. What is image? I told you many things. Actually, you must remember that. And then third thing, then you'll ask Rajesh, from where you should download. From where? Guys, VMs you download from the internet. So there also we go and download from internet. So from where you download the Android app? Can you please remind me?
App
Or
Store.
maybe some of you must be having Apple mobile.
Apps too.
From the App Store.
Yeah, App Store. So conceptually, what do we call it? That App Store and Play Store, what do we call it?
The repository.
No, we call it registry. Okay, always remember. registry. This conceptual keyword is a registry. That means Play Store is a registry conceptually, and App Store is a registry. Okay, so registry, GitHub is a registry. So registry will have a repository, repo, and then repo will have their app version of file system, version of file system. Simple concept. Okay, that means in your app store, when you go and download the WhatsApp app, this WhatsApp app contain one repository. If you go for HDFC Bank app, so one repository. So they have a multiple of thousands of repos actually they have. Okay, so this is called project or repos, depends on the companies. Okay, so here then you'll say, Rajesh, I need a registry where I can download this image which is in repo. Where is that? So we have a one public repository which is called hub.docker.com. Okay, this is the one. And here you see this website got changed a little bit. See, these are all the images actually. See that. See, these all image, Ubuntu image, Python image. Python means what? Python means some base, some user, and Python. Postgres, Ubuntu means only this much. No applications installed. Okay, BGBox like this. See, MySQL applications, MySQL image, MongoDB. How many images you have any numbers? Actually, this UI got changed and I don't like it, because earlier the numbers of images which we were presenting somewhere on top of it, but it's removed actually. You know what? In this place, you will get more than 1 lakh image. Yes, 1 lakh image. So what we will try? So here, hell lot of applications image are there. You just name it, you will have it. But I'll go for the Apache because that's one of the simple applications, web-based application, easy to understand that. See, HTTPD. This is the official image. You can see the filter left side, uh, trusted content, operating system, architecture, all this thing. You can filter it. So this is the Apache image, and this is the image. This is the one repository. Okay, one repo. So hub.docker.com is a registry. This is a repository which contain the image of HTTPD. The name of the repository is HTTPD. Okay, so from where you'll download? So you will download from the hub.docker.com. By the way, it's not like we have only one registry. We have multiple. Google has a registry, Azure has a registry, AWS has a registry. A lot of registry. You can set up your own registry using Nexus or Artifactory in for the enterprise companies and all. So all this thing you have it actually. Okay, so from where? So you will download from here, and then what to do? This is the step 3, right? And step 4, I'm going to teach you what you need to do. Remember this one? Get a container, start a container, stop a container, restart a container, kill the container, pause the container, and blah blah blah. So these are the 4 things you have to do, and I want you to finish it off this one as soon as possible. I'll show you the demo now. So are you okay with it, all of you?
Yes.
So now I'm going to show you the demo. So I have a Docker installed. I want to download the image. How to download? So guys, I will ask, hey, I want you. So here, pull this image. That's all. Automatically it will pull from the same registry. Docker images. See here. Earlier for certain demos, I downloaded this one. Today I downloaded this one. Before that, there's a few commands you should run. For example, version. Okay, check that. All this command I'll share with you. Docker-v, Docker info. Read all these commands and stuff like that. Now, what to do? So guys, just remember only this line. I want to create a container. So Docker PS. So Docker PS is a command which will tell you all the running containers. So right now I don't have it, but here if you see the column ID, container ID from image container running with this command, created status, port, and names. So now ps-a means running and stop container. So this container I used it for some training, okay, 5 days ago. So it's still exited. Just leave it. I don't care about this. So how do we create a container then? So Docker create From what? HTTPD image I created. PS I created, but it's not running. So PS will not tell you. But if you do the PS-A, it will tell you. Now you see here, this container, which is created from HTTPD, container ID created, name. Each container will get a random name, unique one, and then 9 seconds ago, running with these commands. So now I created this, so simple. Now start. Can I start? So contain Docker start, and then container ID. And you see now PS-A, see, up means running on 80 port, internally is taking the 80 port, and then it's running. Now what to do? So I'm going to stop it. Same command. Now you know that, so you don't need to stress too much. Stop. See here, exited. So when you stop the container, the status is exited. Again, you want to start it. Start it. Again, it's running. See, up. You want to restart it. Restart it. See here, restart it again. So you want to pause and unpause. Let me show you. Docker PS. You want to pause, and you see here, paused. See, paused. So paused container will not have a CPU allocations. Okay. So Docker stats. You'll see that CPU is 0%. See. So paused container will have a memory utilizations, but CPU will be 0. Stats command you can find out. Okay. So you want to unpause. Let me unpause, and then see, now it's unpaused. Okay. So it's so simple. Create, start, stop, restart, pause, unpause, and finally you want to kill the container. So kill and stop, what is the difference? Both will get you the same results, but stop is graceful, kill is forceful, something like that. So here, kill, here, gone, exited, see, exited, and you want to remove it. Docker rm. You can use the container ID also. By the way, for any operation, you can use the name also. Name is also unique. I'm using name and gone. Tell me, was it difficult, all of you?
So the Docker image just runs as a process?
Yes. Docker container runs as a process. Image is just a files, mind it.
Yeah, Docker. So that is why it doesn't need a
Yeah, it's
bootloader.
running as a process. Yes, you're right. We'll discuss a little bit in detail, not now. So tell me, was it difficult to work with the Docker and container? So now you
No.
will say, Rajesh,
So,
okay, fine. Yeah, tell me.
in order to remove the containers, right, you are using Docker RM, and that
RM. Yeah, RM.
based on the container ID or whatever the object that we
Yes,
have,
yes.
right? So, but i- can we delete remove multiple at a time just by
Yes, yes.
using?
Yes, I was doing simple. See, create. I'm creating multiple one. Okay, HTTPD 1, 2, 3, 4, 5, and now Docker PS-A, Docker RM 1, 2. I was just showing you simple one, but all this thing it can is possible.
In order to remove multiple, we have to give every time we should
Got
use the container IDs, right? I mean, without IDs we
yes.
cannot. Okay.
ID or name, both are
I mean,
unique.
whatever the object, but without giving any
Yeah.
object, we cannot delete the whole list.
No, no.
Okay.
Okay, so now this is something which we have. So now you will say, okay, I got the containers. Which containers I'm having? Docker PS-A. I don't have
So
any
if you,
container, right?
one question. So you are just using a pre-built uh, image, right?
Ah, hmm.
So you're not building an image using a OS image.
No, no. We are not. In this session, we are not doing it, but in future session, here I'll teach you. Okay.
Okay, got you.
We are using some of the image which is developed by what do you say, community. Man, hell lot lakhs of image developed. Actually, you can develop your image also, that's not a big deal, but we are going little bit in a process wise, so you will understand everything. Suddenly if I jump to create image, you will understand what is image, where to use it, all these things. So one by one. Okay. Okay, so guys, this is the one. So now you'll say, Rajesh, okay, fine, I created a container using this command, that's okay. But how to use it? How to use it? That is a question. So guys, there is a container which is here. I'm going to start this container, Docker start, and you see here it's running. Let me ask you one simple question. When you create a VM, what you do? Tell me. When you create a VM, what you do?
We
Virtual
set
machine or
we set RAM, space, and network
no,
IP.
no, no. You created. That is after setting only you created. You got it this VM running, I said. What do you do?
Okay, we create.
You just
Okay.
run apps and then use it.
Yeah. So I'll put it in simple way because probably you're not understanding my question. My question is little at very high level. So see, when you create a VMs, no matter where you create, or you have a laptop, and what you do? So basically, what you do, you log in to VM, don't you? Go inside it, or access the VM using network from outside. Network means HTTP port or da 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 kind, correct? So now, mind it, when you want to go inside a VM, using what you go? Shell, correct now? All of you? See, I'm using shell. This is the Linux VM. Which shell? Which echo dollar shell? See, bash shell I'm using, right? And Windows PowerShell. PowerShell, you see here, PowerShell here you Windows PowerShell. It's the PowerShell. So here, when you want to log in, how do you log in? How you want to go inside the compute unit, you use a shell, bash shell, const shell, PowerShell, I don't care. Okay. Now, when you want to access through the VM networks, then you need IP address. Agree with me or not? All of you? And port number. Correct now? Default is 80. Correct now?
Yeah,
Yes.
Okay. So question is, how do we go inside this container? So straightforward. How do we go inside this container? Mind it, I'm in the VM right now. I'm taking you to container. See here, what I'm saying? Hey Docker, execute what? Bin bash. Why bin bash? Because I'm a human being. I need a shell to interact with the compute unit. Human cannot interact with the compute unit without a shell. Either you use sh bash con and in Windows PowerShell and all, you have to use it. So I'm saying, hey Docker, execute what? This shell. But in what container? This container. But interactive mode means I want to interact. Guys, where are you right now?
you are inside the container and the
Beautiful.
Apache.
Yes. You are inside a container. You are not in VM. And whatever you are seeing, it is inside the container. Let me show you here. CDLS. This you are seeing. Look at this. These all are root file system. I repeat, root file system. I told you in images we'll have a root file system. So this is inside a container. Do whatever you want, just like you are working on operating system, just like you are working on the laptop, just like you're working in the VM, you work in a container likewise. Okay, so this you are inside a container. How to come outside of a container? Exit. Inside a container, outside of a container. Simple. So that is the first thing you are done. What to do inside that? That is a different question. Now you'll say, Rajesh, I want to access the container from outside. So you can access from outside using IP address and port number. So that's the reason I ran the Apache container, because Apache is running on 80 port. I can access from outside also. So let me access. So how do we get the port number? So IP address. So Docker ps and Docker inspect command. These all commands you'll run it. I'll give you, don't worry about that. And this will give you a lot of data, but also IP address. So guys, this is your IP address. Okay. So this IP address I'm having, and after that, this IP address is curl HTTP. I'm accessing this IP address in that machine only. A default port is 80. See, it works. That's your Apache website homepage. Got it, all of you? So I am able to go get into that using shell, and I'm able to access using IP address and network. So guys, was it difficult working with it, all of you? Hello?
Yeah, able to follow.
Yeah. So what I want all of you to get your hand with all these commands which I ran from here, to here, and see, and then get comfortable with it, because the moment we deep dive into the topics, we will use a little bit
Uh,
technical stuff, then you
ca-
get
Can you
confused.
can you please add that three kernel important question as well?
Yeah, I
Uh,
will add it. I'll send it to you. I have a different pages for it. I'll send it to you. Recordings also you'll have it. Don't worry. Okay, all of you.
Have any issues with our channel membership, you can drop an email to us at contact@devopschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Thanks for watching.